Hello everyone, welcome to Wings of Physics. Myself Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. We will continue our chapter Structure of Atoms and Nuclei, and today's lecture is lecture number 4. In this chapter, we will study the Rydberg formula for spectral line of an atom. The Rydberg formula. Question may ask, derive an expression for the Rydberg formula for spectral line of an atom by using the formula of energy of an electron, or derive an expression for a wave number. This formula gives you the formula for wave number. What is wave number? We know that if lambda is the wavelength, then the reciprocal of wavelength, that is called wave number, and the Rydberg formula gives us that wave number, and therefore we have to calculate the Rydberg formula, that is also called as Bohr's formula. Okay, without wasting the time, we will start the lecture. Then we already studied that the derivation for the energy. What is the formula to calculate the energy? Energy in nth orbit, that is minus me z square e raised to 4 divided by 8 epsilon naught square n square and h square. Okay, this is the energy of an electron in the nth Bohr orbit. Now we also studied that this is the nucleus, then this is the ground state orbit, that is nth orbit. This is nucleus, then nth orbit, then this is the mth orbit. This is the mth orbit. Now, as number of orbit goes on increasing, its energy goes on increasing, and this is the ground state, that is the stable state. And the mth state, that is the unstable state, that is nothing but excited state. मग आता बघा, जेव्हा इलेक्ट्रॉन हा एक्साइटेड स्टेटमध्ये जातो तर तो अनस्टेबल असतो आणि तो नेहमी स्टेबल राहण्याचा प्रयत्न करतो. त्याच्यासाठी तो काय करतो तर हायर एनर्जी ऑर्बिट मधून लोअर एनर्जी ऑर्बिट मध्ये उडी मारतो, ट्रान्झिशन करतो, आणि त्यावेळेस जी एनर्जी बाहेर पडते दॅट इज नथिंग बट एनर्जी ऑफ फोटॉन. इलेक्ट्रोमॅग्नेटिक वेव्हच्या स्वरूपात एनर्जी बाहेर पडते आणि ती कशाची एनर्जी असते? फोटॉनची एनर्जी असते. म्हणजे जेव्हा जेव्हा इलेक्ट्रॉन हायर एनर्जी ऑर्बिटमधून लोअर एनर्जी ऑर्बिटमध्ये उडी मारतो त्यावेळेस तो काय करतो? एनर्जी रेडिएट करतो इलेक्ट्रोमॅग्नेटिक वेव्हच्या स्वरूपात. आणि इलेक्ट्रोमॅग्नेटिक वेव्हची एनर्जी म्हणजेच फोटॉनची एनर्जी, आणि ती कोणत्या फॉर्म्युल्याने मिळते आपल्याला? एच म्यू या फॉर्म्युल्याने मिळते. आणि म्हणून बोर्सच्या अकॉर्डिंग टू दी बोर्स थर्ड पॉस्ट्युलेट, दिस em मायनस en that is equal to h mu. Understood? म्हणजे जेव्हा when there is a transition of a electron from higher orbit to lower orbit, at that time the energy radiate in the form of energy of a photon, and energy of photon that is given with the help of formula that is nothing but h mu. H is the Planck's constant and mu is the frequency of radiation. Understood? And this mu frequency, that is nothing but the c by lambda. C is velocity of light or velocity of this electromagnetic wave, that is nothing but 3 into 10 raised to 8 meter per second, and lambda is the wavelength of that light which is emitted. Understood? Now we know the formula for energy in nth orbit, that is this one, and in mth orbit it becomes em. Therefore in mth orbit it becomes minus me z square e raised to 4 divided by 8 epsilon naught m square h square. Then minus that become plus, minus into minus, it become plus me z square e raised to 4 divided by 8 epsilon naught square n square h square, that is equal to this hc by lambda. Okay. Now next step, that is if that me z square e raised to 4 divided by 8 epsilon naught square h square, that is taken as common, inside bracket we can write 1 by n square minus 1 by m square. Okay, and here hc by lambda. Then if we transfer this hc, then here 1 by lambda is here and hc, therefore that is nothing but the 1 by hc. Now this h into this h, it becomes h cube. Then this c is here and this is the formula. Then the value of this bracket, that is nothing but the Rydberg formula, and therefore the RH, value of RH, the value of RH, that is equal to the me e raised to 4 divided by 8 epsilon naught h cube and c. This is the Rydberg constant. This constant is called as Rydberg constant. Rydberg constant. And its value is, value of RH, that is equal to 1.097 into 10 raised to 7 meter inverse. And later on we have to use this reciprocal 1 by RH, that is equal to, now reciprocal of this value, that is 10 raised to 7, and that is nothing but the 912 Armstrong unit. We have to use this shortcut in so many numericals. Understood? Therefore reciprocal of RH or R 1 by R, that is equal to 912 Armstrong unit, and therefore the rearranging this equation, we can write here 1 by lambda, that is equal to RH, this z square, divide into 1 by n square minus 1 by m square, and this formula is called as the Rydberg formula for the spectral line of an atom. And by using this formula, we can calculate the every wavelength of every line which is present in case of the Lemon series, Balmer series, Paschen series, bracket series, Pfund series. Understood? And so this formula is very, very important, and from this formula the shortest wavelength, longest wavelength of any series we can calculate very easily, and therefore this is the derivation for the Rydberg formula. It is also called as Bohr formula for spectrum line of an hydrogen atom. For hydrogen atom, Z, that is equal to 1, and therefore for hydrogen atom this formula becomes 1 by lambda, that is equal to RH inside bracket 1 by n square minus 1 by m square. And always keep in mind that m is the higher energy orbit, means, and n is the lower energy orbit. Understood? And I hope all of you understood all this all the concept about this formula, and this is the shortcut. You have to use many times these shortcuts. 1 by R, that is equal to 912 Armstrong unit. Okay. Then if you like this video, then like. If you want to share with your friends, then share it, and also subscribe my channel, and also press the bell icon so that you will get notified about my new upcoming videos. Thank you very much.